Hello, ladies and gentlemen. This is Mr. Gonzalez again. Here we go with our new lesson. This is for Monday, and the homework is going to be for Tuesday, May 2nd. Okay, now we're going to graph square root and cube root functions. We have done lines, we have done parabolas, we did absolute value, and now we're going to do square root and cube root. Then we have after that we have exponential functions, and I want to see how much can I teach you guys because we're running out of time, and the kids are going to be in geometry. They have to know as much as possible, right? So they can do good in that class. Okay, let's begin. I wrote here the instructions on how to graph a square root in the calculator. Okay, remember, just like the absolute value, when we did absolute value, we did y equals, it went to math to the right number 1. Now for the square root, we have to go to y equals, but we have to press the second function button, that means the blue button, and we're going to just hit the button x squared after. That means y equals blue button x squared, all right? And it will give us the radical function, okay? So let's begin. I ask you to complete the tables, to graph, and label each equation on the axis. We have 3 functions here. We have the parabola, which everybody is familiar with that. We have the positive root of a square root function, and we have the negative root of the square root function, okay? Remember that the square root has 2 roots, a positive root and a negative root, all right? So I'm giving you the values of x already. So we have to find the values of y. How are we going to find them? On the calculator. Everybody knows how to do that, all right? So with the parabola, I'm not going to waste any time. I'm just going to give it to you the way, because, you know, like the only thing you have to do is just on your calculator, type y equals x squared and go to the table, right? And just find the partners of each of these numbers here on the x values. So remember, this is a happy face. You're supposed to know that, right? Because the value of a is positive. So that means that because it is the main function, okay? Remember, the main function always goes through the origin. So that, what does that mean? That the vertex here is going to be 0, 0, all right? So therefore, this is my vertex, right? 0, 0 is my vertex, and x equals 0 is my axis of symmetry. We're just talking about the parent function, okay? So if you go to the table and write this, and you go to the middle of the table, you're going to find the vertex, which is 0, 0. So then you're going to find the values of negative 1, which is 1, negative 2, which is 4, negative 3, which is 9, and negative 4, which is 16. Once I get to the vertex, the numbers start to repeat, all right? So I have all my values of my parabola, all right? I have all my order pairs, so I can graph that, okay? So let's go to the set of axes here. That's my x, that's my y, okay? So I like to start, when I graph, guys, I always begin from the center. I always begin with the vertex. So my vertex is right here. Now you can pick the negative side or the positive side, because once you get to the vertex, you only have to find the image of the other side, okay, of the parabola. So let me go with the negatives. So when x is negative 1, y is positive 1. When x is negative 2, y is 4. 1, 2, 3, 4. When x is negative 3, y is 9. 4, 5, 6, 7, 8, 9. So I know it's right here. I don't care about this one, okay? I don't care about 16 because I still have enough points to graph my parabola. So the only reason why I did this, because I want to be consistent with that, and I'm going to explain to you what do I mean by that. So once I get to my vertex, what do? I just find the image using my axis of symmetry. So I go to the right ones, and I'm just going to match the other point. Make sure it's the same line. Open up one more, okay? Match that point up, open up one more, and it's right there. So when I have my points, I'm going to do my parabola. And I always tell you, try to do curves, right, guys? Don't do lines because lines are for absolute value, okay? So try to do this best you can, okay? And that is my parabola. That's the parent function of the parabolas. And remember, from that, we started doing transformations, okay? So because it says to label it, because I'm reading, some of you don't leave, okay? I complete the table, I graphed it, now I'm gonna label it. So y equals x squared. Now what I'm gonna do now, I'm going to graph my positive side of the square root function. Now, I know how to find these numbers. Listen, guys. First, remember, if I substitute -4 into the x, it's not going to work because when we have square root, we can't have negative numbers. So I know myself that's going to be an error. I'm going to show you how to do it in the calculator. I'm just going to do this first. So every time you see something negative, all right, it's going to be an error because you cannot have radical -4, radical -3, radical -2. It's impossible, okay? Okay? So up to here is going to be an error. Now from here it's going to change because the square root of 0 is going to be 0. The square root of -1, positive 1 is going to be 1. Now, these one are going to be decimals because that's a decimal, but the square root of 4 is 2. Now, this one, you're going to get it from the table and I'm going to show you how, okay? So let me write it down because I already have it. So the square root of 2 is 1.4142 and the square root of 3 is 1.7321. Now, you're going to ask, Mister, but how am I going to graph that? I will let you know in a second. When you're going to graph this, all right? Look, just pick the whole numbers, all right? Like pick this one, and that one, all right? Because these two are going to be right on the graph when I connect the points. So that means that 0, 0 is right here. When x is 1, y is 1 is right here. And when x is 4, okay, I'm going to skip those 1, 2, 3, 4, y is 2. So I'm going to show you on the graph how that's going to look. So if I connect these points, right, it's going to go this way, like that. Also, remember, don't do lines. Try to do something like little curvy, right? So this one is y equals the positive root of x. Now, how am I going to find now, all right, guys, the negative side? Same thing. Remember now, guys, the negative here, all right, it's outside. But for now, just remember what I said before. Let's ignore this for now. Because remember, I know that was going to be negative, but because -4 in the radical cannot be negative, all these also are going to be error. And what this is telling me is, guys, this. Obviously, the square, 0 is not even negative, not even positive, right? So 0 is going to be 0 no matter what. But now, if I ask you, all right, what is the square root of 1? It's going to be 1. But because the negative side is outside, I'm going to keep that. I'm going to skip this, 2, 3. And what is the square root of 4? Is 2. But because the negative side is outside, I'm going to keep the negative side. What I'm trying to tell you is this, guys. If I ask you to find the square root of 4, all right? Remember, if I tell you, let's solve y equals radical 4. What do you have to do? You're going to say, okay, y equals plus and minus 2. That's where that comes from. This is the positive root of 4, and this is the negative root of 4. The positive root of 1, the negative root of 1. Now, this one is going to be negative 1.4142, and that's going to be negative 1.7321. So now let's graph that one. That's going to be the reflection of the other one. because it's still going to begin at 0, 0. Now, when x is -1, y is -1. When x is 4, that's going to be 4. Remember what I said about the parabola? This is going to be a parabola, but instead of being vertical, now it's horizontal. Okay, so now look, guys. This is y equals the negative root of x. So look what I got. I got another parabola, but what happened with this parabola? This parabola, instead of being open either up or down, now it's open sideways, okay? So that's what the function, the square root function is the opposite, is the inverse of the quadratic function. That means that this one is the inverse of these two together. Oh, these two together are the inverse of that. Now, let me explain to you before we answer the question, how can you get that from the table, all right? And remember, I'm going to do both, all right? Just for you to look at it. So we're going to go to y equals, all right? Let me turn it on first. And I'm just going to go, I'm going to clear that, all right? 2 plus 7, 1, 2. I clear the memory because remember, I always recommend that. So let's go to y equals. I'm going to graph the positive side only, right? So I'm going to go to y equal, but I have to go to second x squared, right? I'm going to put x. Remember, I have to exit myself out. It's very important to do that. Maybe not now, it's not going to affect you, but it's going to affect you when we add numbers to it. So if I go to the graph, look what's going to happen. That is my positive side only. So that is this part of the square root. Now, where do I get this number from? You will go to second graph to the table, okay? And look, it throws you right up to 0, right? Because you're not seeing this number. So what you have to do is you have to go up to -4. And this is what I'm talking about. See, from -4 up to 1, it gives me error. Because what I said before, you can have negative values under the radical, all right? So from 0, okay, those are the numbers that I got before. I'm going to go up to 4 because that's what I'm asking to go up to 4. And here I am. So all these numbers, I got it from here. Okay, so now look, I'm going to add now the negative side because if I want to graph the square root function, I have to do it separate. There's not a button that tells me plus minus radical x. So I have to do the positive first and the negative after. So to add the negative part, you have to use this button, not the minus button, the one in parentheses, negative. Then what do we do now? Second x squared, right? To get my radical, and I'm just gonna type x, exit out, and I'm gonna go to the graph. Look what happened. When I do the graph, I get the other part of the function, or the other part of the square root graph. So if you can see, as you can see, this is the negative part. Look, that it comes from here, all right? So together, all right, like I say, together, they form the inverse of this quadratic function. So the square root function is the inverse of the quadratic function. So now, you're going to see where the numbers come from. Here we go again. Second graph. Now I'm going to have 2 columns. Okay, look at the difference. If I go up to -4, you still get an error. Remember, this is the positive side, that's the negative side. So if I go up to 4, that's what I'm being asked, okay? I already have this for the positive value, and these are my negative values. Those are the ones that are here. All right, so I want to hold that there because I'm going to refer to this in a minute, all right? So I'll go to, now let's move on, right? So remember, every time you have decimals, because we're going to see when we have exponential function, you're still going to get decimals. Don't get scared, right? Don't get scared because just graph, like I said, the whole number, all right? Coordinates and everything is going to fall in the middle. So now, the function, remember this is the square root function together, okay, plus and minus. Y equals plus minus radical x is the inverse of the function y equals x squared. Just what I explained to you right now. Because look, the parabola is this one, and the square root is this one, which is basically another parabola, but instead of opening up or down, it opens sideways, okay, horizontally. So remember also what I said before. If I ask you, right, to solve x squared equals 9, what do? You do radicals, right? Because the radical is the inverse of the square. And you do the same thing on the other side, right? So the exponent kill the radical. Now you have x equals plus minus radical 3. That's where the two roots come from, right? It comes from finding the two roots of a perfect square number. So now we're going to answer questions. The first question says, is y equals plus minus radical x a function? Why or why not? Now, remember, that's talking about both parts of the square root, the positive root and the negative root. So if I graph this, what do I get? I get this graph right here, which includes both. So what do I have to do now? In order for me, all right, to know if that is a function, what do I have to do? I have to do my vertical line test. Do you remember that? Vertical line test? What does that mean? If I draw a vertical line and it touches the x-axis, the graph once, it's a function. If it touches more than once, it's not a function. So in this case, right, let's say if I pick that point, that line right there, right? And I do my vertical line test. So there's my line. Okay. If I do that, hold on, because I don't think it comes out so clear. Look what happened. That line touches the graph twice. It touched the line right here, and it touched the line right here, because we're considering the whole thing. So because it touches more than once, what happened? It's not a function, all right? So what you have to do is write it's not a function because it fails the vertical line test. Okay, that will be the perfect explanation. Is it a function or not? It is not a function because, remember that it's abbreviation, it fails the vertical line test. Now, remember also there was another way for you guys to explain that. Until you remember that, you can also say it's not a function because the vertical line touches the graph twice or touches the graph more than once. Okay, you can also say that. But the rule is that you draw a vertical line, not horizontal, okay, vertical line, and if it touches more than once, it is not a function. Now, they're asking me if only the positive side and if only the negative side, they're asking me if they separate, if they are a function. And yes, they are, because look, what they're saying is y equals radical x a function? We're talking about only the positive side. So if I do the vertical line test, which is this one right here, it only touches once. So that is a function. And also they're asking me if I only graph the negative side. So now we're talking about only this one right here. And it only touches once. My vertical line touches once. So that is a function. So for this case, Your answer should be yes. All right? Yes and yes. They're not asking you why, but if they ask you why? Because it passes the vertical line test. So the ends, the explanation will be both the same for both. So because it passes, okay, the vertical line test. Or you can say, yes, it is because the vertical lines touch the graph only one time or touch the graph only once. Okay? So just to be clear, together, it is not a function. Separate, each one is a function. Okay? So now let's go to something else. Domain and range. Everybody knows that, right? Domain and range means the values of x and range means the values of y. Somewhere right here, values. Hold on, I don't think you're looking at, sorry, my bad. Okay. So, from the parabola, everybody remember the parabola because we did this before, and I'm going to explain to you why. The domain of the parabola are x, it's going to be x equals all real numbers. And the range, which is the value of y, equals all real numbers. And I'm going to explain to you why. Let's go to the table or let's go to the graph. This is the parabola for the quadratic, okay? Look, when you go to the vertex here, when you get to the minimum, look what happened. On the y-axis, all right? On the x-axis, I'm sorry, it goes from -1 to -infinity. And it also goes to +1 to +infinity. All right? Now, on the y-axis, the same thing. And the y-axis, oh, here, no, I made a mistake here, guys. I think, yes, I blew it. Because I also, look, I'm not lying, look. I made the same mistake, okay. Hold on a second. I made the same mistake before. I did it on my notes too. Look, I put y is greater than, all real numbers. Then I realized that it was wrong. Because what happened here is from the 0, right? It started going in both directions to the positive side. So here it should be, my bad, let me erase this. It should be let me write it over here. Y is greater or equal than 0. That will be the range. Y is greater or equal than 0. Guys, I'm gonna stop for a second because my calculator, my battery, I think I can do a little more. Then I have to just charge my phone because it's running low in batteries, all right? So, like I say, look here also, guys, look at the graph. If you come on the domain, the x values is going from -infinity, gets to here to 0, and it goes back to +infinity. So in the x values, it goes in both directions, -infinity and +infinity. Now on the y values, remember, the range, it gets to 0 and it bounces back. So it touches only the positive values of y. That's why the range is all y equals greater than 0. Now, if that would be a set phase, it will be then greater or equal than -1 because it will be, it should be less or equal than 0 because it will be going to -infinity, all right? On the y-axis, we're talking about the range, all right? Now, with these ones, the domain on the range of the positive side. Take a look at the positive side here. If you go to the table, eliminate everything when it says error, all right? So look, on the x values, it starts from 0 to the +infinity, and on the y values also start from 0 to +infinity. So in this case, okay, in the positive side, the domain is going to be x is greater and equal than 0, and the range is going to be y is equal and greater than 0, all right? Now, in the negative side, the domain is going to be the same. X is greater than or equal than 0, but the range is going to be y is less and equal than 0. Why? Because if you go to the table, right, you can clearly see that you have to eliminate error. So where do the y values start? From 0, and it goes what? -1, -2 to -infinity. That's why the range here is different than that. Now the domain is the same. 0, 1, 2, 3, 4, until positive infinity. So as you know here, right guys, the domain is going to be the same for the positive and the negative. The domain is going to be the same for the positive and the negative root. But the only one's going to change is the range, because in here, in the positive side, go to positive infinity, as you can see from the table, and on the negative side goes to negative infinity. You can also see this in the graph, okay? On the x values, start from 0 and it goes to positive infinity. And also the y goes into positive infinity. But on the negative side, the x values goes to positive infinity, but the y value goes to negative infinity. So you can get the range and the and also the range from the table or from the graph. But on the homework, you don't have to graph. I don't think you have to graph. I'm not sure. But if you don't know how to find the range and the domain, just graph it and go to the table, and when you start seeing error, stop. And it goes from 0 or for after error down, okay, or to the positive, whatever direction is going. But everything that says error, you have to eliminate it. So let me stop for now, and I'm going to do the other part after, because my battery is dying, okay? I'll be back in a second.